All right, good day everyone. This is Jason Street with the Cloud Pass Virtual Group. Our presentation today is preview of the Spectral Core Cloud First database tools. And our presenter is Damir Bulic. And apologies, Damir, if I get any of the pronunciation wrong. I forgot to just verify that with you.
It's good enough. Thank you very much for calling me.
Before we get started, just have a few announcements here. So the first thing is that this virtual group is supported by Microsoft Azure. Microsoft Azure supports this virtual group and hopes to help people get more familiar with database platforms built for the cloud. If you are not yet a member of the Cloud Virtual Group, I do recommend becoming a member. You can do so by going out to cloud.pass.org, and from there you can click the login to subscribe, and that'll get you signed up for the virtual group and for the newsletter. Over the next few weeks and months, we have a number of sessions that are scheduled, so always be checking that out. We have lots of things coming in the pipeline. Power BI topics, data synapse coming up this Thursday. Lots of different opportunities to learn more about building out your cloud data platforms. Even though we have a number of sessions scheduled, we are always looking for more sessions. I try to do sessions every Tuesday and Thursday. So if we have sessions, I will get them all scheduled up, and we're pretty solid going through the middle of June, but after that, there's quite a few more months and lots of opportunities. So if you'd like to, you can reach out to me at cloud@pass.org, or if you'd like, you can go to the Call for Speakers link on the virtual group website. I should have already taken this slide out because this actually closed the Call for Speakers for Pass Summit 2020. So they are right now looking at those, and the sessions are being evaluated. So we should know in just a couple months what all the sessions will be for Pass Summit 2020. If you are not currently registered and are planning to attend the summit, you have the opportunity to save a little bit of money off of your registration. You can save $150 US off your registration using the discount code that is listed there on the screen. This virtual group is part of a number of virtual groups that PASS helps to support on various different subject areas. These are other great areas where you can learn more about building out data platforms. If you have any questions through the session, please type them into the question panel that's on the GoToWebinar panel. That'll help us to know who's got questions, and we can go through them all at the end and give Damir an opportunity to dig into those. So at this point, we are ready to get things kicked off. So I'm going to hand the presenter over to Damir for preview of the Spectral Core Cloud First database tools. All right.
Hi, everyone. I hope
should have the ability to present. And yep, I can see the tool coming through right now.
All right. Hi, Jason. Thank you for having me here and the opportunity to show what we are building here. I hope my voice is fine. You just let me know if something is amiss here. Okay, so let me show first who we are. So we've been making database tools for a while now, for the past almost 20 years, and we've been a desktop software company for all that time. And most of those years I've been a solopreneur. So basically I built all the software myself, the website and everything. And during those years, the niche that I built the software for was database migration. And you can see that we support some database formats, and that's how it went. And a few years ago, I started wishing basically to expand the products we've been making and push to the cloud, because it's extremely interesting actually. And I'm going to show you how far did we get now. The team is a bit bigger now. It's 4 of us at this point. So this is, I'll start showing the desktop software that we have, and then basically you'll see how we are evolving this into the cloud first software. And the first thing here to show is this is called full convert. It's a product to basically copy a database from one format to the other. Or, I mean, people also use it to copy database from one format to the same one, but perhaps in a older version. That's not so easy going achieving that with backups. So let's just take a look at how this actually works. Say I want to go from SQL Server and copy that to Postgres. So what I'm going to do is basically pick up SQL Server, connect to one database, pick up then target, connect to the target database. Let's go here. It's like a little wizard, super easy. Okay, now we see something somewhat special here, and that's parallel workers here. So parallel workers allow you to do, let's go with one in the beginning. So we can copy this very quickly. So I'll just go ahead and do it. Okay, so we're going to recreate all the tables and copy the data, then create the indexes and foreign keys. It won't take long. It's AdventureWorks, that's a demo database from Microsoft. It's super quick. Okay, it's not very large. So that's it. But now we can go and look at the details. How much time did you spend actually copying this? But let's see if we can do better than that. Let's go to project options and say, okay, let's do 8 parallel workers. So what's that going to do is copy things in parallel, and not only copy in parallel. It will drop tables in parallel, create tables in parallel, create indexes in parallel, and let's give it a try. So with dropping, it takes a bit more because it needs to take care of the order. All right, so it's pretty fast. Basically, the whole database was copied in 2 seconds. Okay, database is tiny, but still, it's easy. Okay, so that's one thing that we are doing with this software. It's let's say the philosophy of what we are making is hide all the complexity, abstract it away. We're connecting to each database in a very specific way, not relying to just ODBC or OLEDB. We're talking with native database drivers and adjusting to the format of each table and adjusting the way we talk to databases, reading their system tables directly. So we want full control. But okay, we'll talk a bit more about that. Let's now try data replication project. You can see it's the same thing. So the wizard is practically the same. Let's go here. So I loaded to save some time. I just loaded one of the projects. It looks exactly the same, but it says data change replication project. So what it does, it will compare. For example, we can first compare tables, and we can compare them in parallel. So we compare data from the source and the target database, and we detect all the changes. And now we copy them in earlier, so it's there are no changes. They're exactly the same. And let me check, where did I put? I have it here. I have pgadmin, so I'm going to make some changes. And of course I messed something up. Let's see. I was going to test. Let's go to query tool. Okay. Perhaps something like this. Okay, so now what I did is I made changes on the target database. So when we compare again, it should detect them. Okay, it says there. So here we have 70 tables with the same content, and one table has some differences, and we compare them in 3 seconds. So let's go and see the differences here. I can, of course, show all the tables or only the ones with differences. If you go and take a look, you can see that the modified date has changed for all of them. It should display it here. I wonder why. Of course, when I'm presenting something breaks up. Okay, so what we can do now is we can replicate those changes. So it says, look, I updated 19 changed records, and there are also 760,000 records that we didn't touch. And what we do here is just precisely updating the target database in place. So what's really the power here? You know, we support some 40 database formats. That means, and we are comparing the data. When you are trying to replicate data changes, there are several possible approaches. One approach is what we are doing here. It's maybe the most brute force approach, is just compare everything and detect changes yourself. There are some advantages to this. The second possible approach is to use triggers and temporary tables. So but then you have to pollute your source database, source production database, with perhaps hundreds of triggers. And that slows things down, and it adds a point of instability into production. I myself would hate this, so I didn't make this into the software that I sell. And the third and the best approach is change data capture. And change data capture basically is allowing you to listen on the changes in the source database as they are made, and then apply them in real time to the target. That one is the best, but not many databases can do that. So in our philosophy of making things easy, we opted for the compare and then replicate just the detected differences. But as you can see, it's extremely efficient. So one thing that we can get from this is we support 40 databases, which means you can say, okay, I'm getting, for example, Excel files with updated data every day, and I want to sync them to my production database that's on a remote server behind the firewall. So what you can do is you can sync those Excel documents and replicate them over SSH tunnel or SSL. You can replicate them to your protected server extremely efficiently, and then you will also get these 19 change records updated, even though the source database is not even a relational database. And so you can do this with standard text files, CSV documents. You can do it with ancient DBase files, paradox files. We believe it's important. So this is a panel for the cloud tools, and what I shown you is basically desktop applications, but it's a step to the further software that we built now. So what we want to do is, this software is extremely easy to use. It's comfortable. There are no many surprises. It's basically point and click, and don't really have to ask much. And when we are going to the cloud, we are always having compromises, and we want to basically make software that's as nice and easy to use as desktop software just for cloud. But okay, so let's see the next stepping stone in this case. The product that we built, you saw now the full convert desktop software. It allows us to use up to 16 parallel workers to copy data from one point to the other. And you can use it to also copy data to the cloud database, between cloud databases, no problem at all. But we can go further. We built a software called Omni Loader. And okay, let's see. I hope that you can see this. It's large enough. Okay, so Omni Loader is a desktop application. It's a web application. This one, it's a Heroku add-on. We're just testing it, and it allows you to use most of the database that we support now, and in the near future, it's going to be all of them, to push them into Heroku. For example, if you have DB2 database, you need to copy that to Heroku. You can use full convert already now. But what's the difference? Why did we build the web application with the same underlying technology as full convert has? Because everything stays in the cloud. With full convert, you need to process data on the local machine, and that takes time. That takes bandwidth. There's latency. There's ping. So one thing is we put our data processor in the same spot where your database are, so it's much faster. And the other thing we did, it's cross-platform now. It's also infinitely horizontally scalable. So if you had full convert, which allows you to use a certain number of parallel workers to speed things up, with Omni Loader, you can have as many parallel workers as you want. We have a concept of agents. So this web application is just an orchestrator for the agents. And what we are having here is basically a distributed cluster for migration of database to reach any number of records per second or megabytes per second that you wish. If you want to speed things up, just add more agents. And each agent is like a little copy of full convert. So each agent is a separate machine or a separate virtual machine, whatever, with independent connections. Each agents are independently connecting to the source and target database, and then executing the tasks that the web application that the orchestrator is demanding. Let's just skip this a bit. We have some connection that's not going to be very interesting for you guys. Okay, so what we have here, and I hope we can see it. We have now connected to. Okay, let's zoom in a bit. We are copying from one server to the other server. One is on Azure, the other is on Azure, but we had some time constraints. We didn't have time to copy the Heroku machine to the US. So this, what you're going to see now is copying data from, data is traveling from US to European Union and then back to the US. So it's like the worst case scenario for Omni Loader. But let's see how well it behaves. What we have here is 10 agents, so 10 machines doing the work. Each machine has, this is the number of workers. And if you have powerful agents, you don't need as many of them. Why are we scaling to agents instead of counting on the single machine with, for example, 32 cores to do all the work? Because it's pretty easy to saturate a single machine. It's pretty easy to basically saturate the disk. Even on cloud, it's even in the cloud, it's much more efficient to have several different machines doing the work at the same time than hoping that the single machine will do. And there's a limit to the vertical scaling, so horizontal scaling is the way to go. Okay, let's see what we can do with this. So we have, just a moment, it's going to start now. Okay, so we are creating tables and parallel, so that went very quickly. And now we're going to copy data. Okay, let's zoom in a bit. So what we have here is 80 jobs. It's just started. We have some 700 tables. So it's 80 jobs copied in parallel. 32 is already done in this 1 or 2 seconds it took me to take a screenshot to zoom in. And we can see that we have throughput of 100 megabytes per second or 350 gigabytes per hour. And as I said, this is not even an optimized process right now. We're going from US to European Union and back. And throughput is right now 130,000 records per second. Okay. And it's doing its work. You can see there's 80 jobs in parallel, but we can really go as much as we want here. We're going to iterate on the user interface. This is somewhat incomplete as we're replicating the UI from the desktop software to the web. But this is already useful. So right now we are building this, testing this on Heroku, then it's going to go in Heroku marketplace to the beta stage and then to the general availability. Okay. Besides Heroku, we are planning to release this to all clouds. And so it's going to go to Azure, it's going to go to AWS. So if you have databases that are all on AWS, you can simply fire up our software in the same data center and blazingly quickly copy them or replicate them, because it's going to be using the same engine to copy to compare the tables that Full Convert is using. They're also going to add compare CDC. So that's it. I hope this is easy to see here. I have a funny video today. We just tested how quickly are we detecting the agents. So the idea is to allow you to dynamically add or reduce, increase or decrease the number of agents that you're using, just for the cost purposes, cost optimization purposes. So we fired up the Heroku dashboard, and we have our application with 2 agents. We're going to now increase the number of worker dynos here. So we increased it to 10. And as soon as the Heroku fires up new agents, they'll connect to the orchestrator. And you can see we now have 10 agents here. So you can start with a certain number of agents, go through it, and then basically increase to get things done faster or reduce the costs. Okay, and that's basically it regarding the Omni Loader. Now I'm going to tell you a bit about something that's for me personally the most interesting thing that we are making. It's called SQL Trend. And why it's so interesting is because I spent years building my own SQL parser and analysis engine. It turned out it's very, very good. And what we're using it for is migrating code. We're translating code and stored procedures, views, procedures, so functions, triggers. And the software for this was ready and having been sold 5 years ago. However, it's an enormously hard problem. And how I made it initially, it required the rewrite or additional programming for each combination. So I stopped selling it and basically waited a bit, a few years until it gets to the turn. So now we're going to start selling it again, and the new engine is much more powerful than before. But let me show you what I built 5 years ago, just so you can see how powerful it is, and then we'll see how we're building on this technology, like from 5 years ago, to the latest and greatest product that I personally think is going to be the backbone of our business very soon, even though all of the things I'm showing you are very, very useful. Okay, so it's called SQL Trend, and SQL Trend is the product I made to translate from SQL Server to Oracle, and the idea is to go also from Oracle to SQL Server. Nowadays, almost everybody who asks about SQL Trend wants to go from SQL Server to Postgres. I also believe there'll be a ton of companies want to go from Oracle to Postgres, but let's go one at a time. Okay, I'm going to skip a bit. So this is the connection. Okay, so what we can see here, I hope it's easily visible here, is that we have all kinds of things that were working like 5 years ago, and now it's being rewritten, the new technology. Let's zoom in a bit. We have, okay, give me a second till okay. So we have find inside objects. This is real-time search. We have Scratchpad which allows us to play with the database by writing the code and it being translated in real time. We have project objects, which means it lists all the objects that are currently in databases, and we have tests. There are some other things we don't really need to talk about now for this initial webinar, but so we have 98% of translation. So that was 5 years ago. It's better now. Okay, so again, we are migrating AdventureWorks here, and it's a tiny database. It has 2,500 lines of code. However, this product was tested with, I think, 250,000 lines of code. It worked great. But why AdventureWorks? Because it's very, very Microsoft specific. And we managed to migrate it to Oracle, fully automated, and with much better results than the competing products, at least at the time. We'll need to see how much more did they catch up in the recent years, but I'm pretty sure it's going to be great even then. Okay, let's see how this product works, and also keep an eye on some parts of the functionality that we're going to build into the final product that I'm going to be talking now today. Okay, so we have tables. Let me stop this here. So we have a source definition and a target definition. Source definition is what we read from the database, and the target definition is what SQL Train, how SQL Train rewrote that source definition. You can see that the source, it was, I believe, the target for this specific project was Oracle 11. Oracle 11 doesn't have identities. So we created a sequence, we created a table, we created a trigger using that sequence. So we're basically doing the best practices to achieve the same outcome in the same way that Oracle developer would write by hand, at least for a time. Okay, but besides, okay, this is also, for example, just somewhat interesting. But before I move on, so it's not only a blind migration, meaning we parse the source script and we try and figure out what's in there and then write what we hope is good. We're using static analysis, so we have our own parser, which is extremely fast, much faster than what's typically used in the world today. And what our custom built parser allows us to have our bespoke custom static analysis engine on top of it. So we use it for things like this. We have, okay, so here we have steps of the migration. We have tokenization, semantic analysis, and then we are doing static analysis. And then the last one should be if the target is correctly created in the target, if the table is correctly created in the target database. However, let's see this part down. So this is the benefit of having own static analysis engine. We are analyzing the code and looking at what that code does. So we can see for this specific table that it's being read by many different things. It's being read by this trigger. It's being read by this view as a part of a table source, and by this one and this one. And it's being used also by this function and by this procedure. Then we also have these red ones here. We are seeing who exactly is using this table to write to it. So when we are touching the table in our everyday work, we can see what we are exactly impacting here. And this analysis engine is going to be much more interesting soon. Okay, let's go a bit further. It's not. Why am I using the video to show you this instead of using the application live? As I said, this is a 5-year-old version, and right now we have completely rewritten the underlying engine for it. It cannot even start. I cannot even activate it on our server because in the meantime the activation process is changed. You can see here that we are also migrating XML. So it's pretty advanced. We have some things that were not being able to be migrated at the time. You can see we have some unresolved references, and in this video I'm showing that it's because of the full text search, which we didn't support at the time. Okay, let's move a bit further. Okay, so this is interesting. Give me a sec. Let's try. Let me find the procedure. Okay, so here is how we are migrating a specific procedure. And you can see that we are able to migrate CTE. Okay, so all of this is a CTE. We are migrating it to the equivalent here. And we have, so as I said, this is somewhat limited 5 years ago. Right now we have, last time I checked, we had something like 3,500 of tests only for the parser, and all of the SQL constructs in all of the dialects that we support. And we're not done yet. It's extremely hard problem and pretty hard. And we're a tiny team, but we're going to get there pretty soon. I'm showing here then on the video how we are creating everything on the target. Some things are depending on each other. I think that one object failed because it depends on a function. Yeah, okay, so this table depends on a function that's created a bit later. So we're going to just repeat this, and then it's going to be created. And there are those two procedures that we didn't manage. Okay, so now comes the more interesting part. Okay, so 5 years ago we had 84% of fully automated creation, but even then it was typically over 92 or 3% for the code that is used by, let's say, the average developers. That's not so closely tied to the Microsoft technology. But okay, so this is the Scratchpad. I'm using it to show you how the syntax analysis works. The static analysis, sorry. So you can see I'm just writing it down, and in the left side, I'm writing SQL Server code. On the right side is going to be migrated to Oracle. You can see that person.person is red. Why? Because we found unresolved reference. We are referencing a table which doesn't exist. Let's continue here a bit. So now when I say in current project, it's using the environment of the current source database, and basically you're selecting from existing table from the current project database. So it found person.person. But let's see what happens if you start writing things that are not part of that table. You can again see that we have, okay, so this is interesting. If I hover over the person.person, I have a pop-up saying, okay, so this is a reference to person.person table. There are 60 references in a whole database to this table, and it has 13 items, 13 table columns. However, this ID, ID is red. It's not part of that table. It's not listed. So let's see what we can do about this. Okay, so now everything is red because I unchecked current project, and I'm going to just say, okay, let's treat this script as an independent script. So now I created table X. I'm going to change it. Okay, so it found ID. It didn't find the business entity ID. Okay, let's see what's more interesting here. Okay. You can see this tiny script on the left side is being migrated to Oracle in real time. So as I write, as soon as there are no errors in the code, so it must not be any syntax errors or the reference errors, in the sub-second it's rewritten as equivalent Oracle code. Okay, so that's SQL trend. I believe that it's going to be extremely impactful on moving people from the Oracle and SQL Server. I think also DB2 to Postgres, and I think the Postgres is going to help Postgres have more demanding users. Let's come to the latest product here, and that's my favorite one. It's called SQL App. We have a tiny, sorry, where is it? We have a tiny website already built for it, even though it's not released yet. And what is it actually? It's a next generation database manager, and it's for the cloud and on-premise databases. However, the accent here is on the cloud, and another accent is for the teams. Database managers, we have hundreds and hundreds of them, and they're pretty much unchanged in philosophy for the past 20 years or so. Some are more polished, most are not even polished. Usually they are slow, and we use them every day. However, for the most of the operations that we are using to interact with databases every day, we use a subset of features. SQL, each popular database comes with the very own tool for the use, and those tools are usually large and slow. SQL Server comes with SSMS, Oracle comes with SQL Developer. For Postgres, we don't even have good specific tools that comes with Postgres. We have commercial tools. We have pgadmin as a open source tool. However, we imagine something different. Let me show what's different. We had proof of concept some 2 years ago. What I'm showing you now is that proof of concept from a while ago, because again, the latest version doesn't even it's not finished. We've been spending a lot of time for the past year or so integrating all those disparate engines from the several products and merging them into a core that we can share among all of our products to speed the development up and be able to, in the long term, provide far better experience. Let's see what are some of the most important philosophy. What is some of the most important philosophy, and what are the most important tenets of SQL App? It was called SQL Studio in beginning. I, however, couldn't secure the domain for SQL Studio so easily, so I gave up. So now here's SQL.app. I hope it's going to be extremely popular, of course. What does this SQL App? What does it have that other products don't have? First, this is a native desktop application. However, it's completely different under the hood. This is our debugging info just for us developers. This is basically a thin client. We have a server that's being always where your data is. We're going to we're going to deploy this engine to all popular clouds in all regions of those clouds. So Say you have data in AWS US East. What would you do? You would basically deploy deploy our API there, and then you can use this client, this native client, wherever you are. And we have the same approach as all the web applications. We are minimizing the amount of traffic that goes from server to the client. And why is that important? Because when you're working with the large databases and you connect with a heavy client there, let's say that you run a query and it returns 1 million records. You have to pull those 1 million records to where your client is so you can display them in a grid. We don't do this. Instead, everything stays on the cloud, and we are just showing you the data that you need just to see it. So instead of 1 million records, we'll fetch 50 records, and when you scroll the grid, this is going to be the grid. I don't think it's shown on this video. You can work extremely quickly wherever you are. So that's one tenet of it. The other tenet is persistence of the workspace. I remember how I was extremely impressed with Sublime Text, because before Sublime Text showed up, when you use some kind of text editor and you wanted to close it, then it would ask you, oh, you have 15 documents open. Do you want to save them? Yes, no, deselect all, and it's a mess. Now Sublime Text came and it basically introduced, at least to me, I don't remember that there was some other software that was popular that had the same approach, where it simply remembers everything, because it tries to assume what's the best for the end user. So you close it and you didn't save anything. When you open it again, it restores the workspace exactly how you left it. So this is what we do here. You can now close this database manager, and next time you run it, it opens in exactly the same spot. It shows you the same database connection, the same tabs, the same documents, even the same grid with the result set that you've been using last time you fired up the application. And the third tenet of the third part of the philosophy here is it has to be instant. We don't want to spend time every time we run the tool. We don't want to spend time on connecting to the desired database, waiting for it to read the metadata, to populate the database tree on the left here, just so we can start working. Instead, we are having users and they're part of the teams. So the administrator chooses as which database users this specific team is connecting, and then we are pulling the connections for the whole team. What this means is basically the server is connecting on your behalf, and you can work much faster. Let's see how this works in practice. So I'm now on this Nuco 4 connection. You can see we have 98 tables. Ignore those little exclamations. It was some problems with the parser at that point in time. So on the left side here, we now have some other connections. On the right side, we see open documents. Then again, ignore the broken UI. And all the documents are tied to specific connections. So instead of having a connection per tab, that's prevalent now in the database manager. So if you have 7 tabs open, first 2 might be related to one database connection, then the 4 to the other database connection, and we don't have this complication, and we don't have this illogical way to do. The much more logical way to do is, if I'm on one connection, I don't care about the tabs and documents related to another connection. I just want to be able to very quickly go from one connection to the other if I need to, but generally when I'm working with one. So I'm going to play this a bit slower. Let's see. Or maybe I can just move it like this. Okay, so I'm now moving much slower. So you can follow the mouse pointer here, and you can see as it goes over the connections on the left side, it will change the documents on the right side and show you what you had. And of course, the idea here is, yes, it's going to tell you that it is 157 characters last used yesterday at 5 p.m. But so when I go to the other, you can see that in I test many tables, I have 3 documents open. And so what happens when I click on this S1G? It immediately populated the metadata with the objects that were present in S1G database. You can have real-time search, you can have real-time filter, and when you write, now we come to the static analysis that I've been showing in the SQL trend. When you write your code, we are using the static analysis engine to point out all the syntax errors as you write. If you, for example, drop a table, immediately you'll get those nice exclamation marks that I've been showing a bit earlier, telling you what broke. Because when you drop something that certain procedures depend on, you invalidate them. If, for example, one user adds a table, creates a table, will notify all the other users in your team in real time. They'll just see 191, and as they are as they're writing the code, the autocomplete will instantly, the same second, start taking that into account. Okay, so this is how it works. You can see it's instant. So idea here is to have everything in less than 100 milliseconds. It's hard. It's much harder than writing just a single monolithic desktop application, which is why it takes us so long. But this is the product that we're going to focus on in the following months, and we're going to launch it first for Postgres only. We'll then expand to the other popular database, but we want to get it right for Postgres, and we want it to be the most powerful IDE for Postgres that exists. Basically, we're writing the database manager that we ourselves love to use. Okay, so now I'm going to just show a bit of the static analysis in work. Let's go a bit here back. So as I write, it's analyzing the code in the sub-second. I mentioned earlier that the parser is extremely quick, and the whole round trip from your editor to the server, parsing and going back takes, I think, 30 milliseconds at this point. I mean, last time I checked, it's maybe faster now. And why is static analysis so important? Because when you have a huge select that's with ton of nesting, certain constructs are visible only in very specific part of your, for example, select statement. And our autocomplete engine is relying heavily on our static analysis engine to provide you perfect results. So autocomplete usually has really a lot to wish for when you work in typical database manager. So one of our goals is to make the best autocomplete engine in any tool. You can see again these all columns here. Yeah, so we have a ton of things in our to-do list, how to improve this. But so as I said, this was just an early proof of concept. Okay, so this is it. I'm done. It's I've been talking for almost 50 minutes now. I think it's now time to answer your questions. I'll be very happy to answer your questions now. Thank you.
All right, thank you, Damir. So we've got one question here right now, and this was from earlier in. It asked, when CopyDB, I thought you said create tables first, then copy data. At which point do you set the foreign key, as it might be better to do that at the end.
Yeah, we are doing that at the end. So the process is like this. In full convert, we check if the target table already exists. If it does, we drop it. Then we create the table. Then we copy. I mean, these are like separate stages, and it's optimal for the maximum performance. So we copy the data without indexes and the foreign keys. And after the old data is copied, then we create indexes and then we apply the foreign keys.
All right, excellent. Also, are create triggers also in similar objects, are those created at the end as well?
Sorry, which other objects?
Triggers and items.
Yeah. I mean, in full convert, if we are creating sequences, we are creating triggers. But full convert is not migrating code. That's for SQL train. So full convert is basically just for the table and data and indexes and foreign keys and sequences and triggers. But yeah, then those triggers that it does support, they are created in the end.
All right, excellent. And those are the two questions we have at the moment. If there are any other questions, please type them in and we can go through those. Oh, actually, here we go. Do you use any of the MS SQL parsers from Microsoft, and why or why not?
Why not? Well, ours is much better, much faster. There's a competitor of ours that also migrates database code. And if I recall correctly, their speed of translation was something like 150 records per second. And last time I checked, our parsing and translating engine was 500 times faster than that. We are able to. Let me see if I can do a quick test here. Give me a sec. I mean, no need for it. But I mean, we can really parse extremely quickly. All of these parsers, I think, they use Yak, and with our very own highly optimized, it's incredibly fast. And we need that speed to how the parsers usually work. You use out of the shelf parser, then you get some representation that you have to massage into something useful. And our parser is basically creating strongly typed objects exactly as we needed in a single pass. So it's you cannot get more performant than that. And we want that performance to be able to have this less than 100 millisecond response going from the client to the server, having everything analyzed and returned back. And then because we want to have, for example, autocomplete as you type, and that it takes into account all of the code that you've written and knows exactly where you are in the middle of a very complex statement. By the way, if anyone is interested and wants to basically be involved into the development of SQL App, if you go to our website, you can request access and then fill out the form. We'll put you on the beta tester list, and you can then have far more influence and criticize us as we work. I would actually very much like this, because it's one thing to have a team of 3, and it's completely different thing to also have another team of 100 people actually using this and telling you what they need to get this done right. And we really much want to get it done as right as possible, as close as possible to being right.
Excellent. And is the long-term target for the tool set cloud to cloud or on-prem to cloud migrations?
So basically, for full convert, it's on-prem to on-prem. For Omni Loader, it's cloud to cloud, but also cloud to on-prem. So Omni Loader is the next step to the cloud. And for the SQL app, it's both. But we are trying to optimize it the most for the teams. I mean, it will work great for the solo developer as well. But I think the most impact it will have on teams, because it will allow the whole team to be incredibly productive. Really, also, there's something I didn't mention. If you want to import your data into the database that you're having, SQL App will allow you to simply drag and drop a bunch of files, and will just import them for you. You can even drag and drop SQL backup. For example, if you use MySQL dump, even now we already have the technology to treat it as a database. So for example, you can drag and drop MySQL dump, and then select which tables of it you want. Maybe we'll even add the ability to set specific filters on tables. And there's a lot of plans, but we have to get this. We have to launch this, and then we can improve. Yep.
All right. And if on-prem use probably don't have, with an on-prem, you probably don't have huge bandwidth to and from on-prem. That could be slower.
Yeah, I mean, if you're moving, if your database is very far away, you want your application to be as close to the database as you can, and we hope to basically bridge this with SQL App. However, for the SQL App is going to be deployed as a standalone application, and then you can just connect it to the team or not. So if you're having everything on-prem, you can be behind the firewall. It will work beautifully. It's just that as it is now, each developer independently is connecting to the same database, asking the same thing. We feel that this is going to really make a difference, especially when you take into account the static analysis that we have. So you can have things like refactoring, analysis of the code you wrote, many possibilities here.
All right, excellent. All right, so those are the questions that we have here today. And thank you for presenting, and this has been great. It's always good to learn about new tools, new opportunities to do and build things out on the cloud.
Thank you.
So
thank you for having the
attending.
patience. Thank you for having the patience to listen to me.
All right, thank you, and everyone have a great rest of your day, and thank you for attending today.
Thank you. Have a nice day. Bye.